Hello, and welcome to today's lesson on solving inequalities. What you'll see in this lesson is that most of the things that we learned in the solving equations lesson will be repeated in this lesson. So hopefully it's going to be pretty easy. The obvious difference in inequalities and equations is obviously the symbol that we use between the two expressions. Instead of an equal sign, we'll use greater than or equal to, less than, or less than and equal to, also affectionately called the gator mouths. And also in inequalities, most of the time we're going to ask you to graph, and you need to remember when you have a filled in circle and an open circle. And you can see that there on the page. So let's go ahead and do an example. So just like an equation, before we can do anything, we want to simplify both expressions on either side of the symbol. On the left-hand side, I have parentheses, which means I have to distribute to get rid of them. So we're going to go ahead and distribute that -2, and we get -2x minus 18 plus 5. Then I have some like terms that I have to combine, and remember, if they're the same sign, we add, opposite sign subtract. Well, I have a -18 and a +5. Those are opposite, so I'm subtracting. 18 minus 5 is 13. 18 is bigger than 5, so I'm going to keep its sign, so it's a -13. And now I can ask myself my questions. What am I solving for? X. How many are there? 1. That's good. We can solve, meaning SADMEP. Get rid of any subtraction or addition first. So I'm going to add 13 to both sides. I get 16 on the other side. Then I have to get rid of any multiplication or division. So I'm going to divide by -2. And here's the next biggest thing that you have to remember. Remember that when you divide or multiply both sides of an inequality by a negative, you have to flip that inequality symbol. So that greater than or equal to becomes less than or equal to. All right, so now we have to graph. And I'm going to assume that a lot of you guys were taught to graph the way this is pointing. And that's an okay way to think about it, but that's not, the math teacher in me is cringing a little bit because that's not how you're supposed to graph things. What you're supposed to do is pick a point on the number line, substitute it back into the original equation. If it's true, shade towards that point that you chose. If it's false, shade away. So on my number line, I'm going to make a little one over here. I'm going to put 0 in the middle, and I'm going to put -8 on the side. I'm going to go ahead and pick a number on the number line. I always pick 0, and then I'm going to go ahead and substitute it back into the original equation. So right here, I'm putting a 0. So I do 0 plus 9 is 9. 9 times -2 is -18. -18 plus 5 is -13. Is -13 greater than 3? And we should all know that that is false. By the way, I should have put a closed circle here at 8 before I started this. Well, I want to shade away from the false. So I go to my starting point, which is the -8, and I shade away. Now, all of you are probably sitting there going, well, why couldn't we have just shaded to the left from the beginning? So again, remember I said the math teacher in me tells me that I want to do substitution. The realist in me goes, well, why don't we just go ahead and do that? Here's the caveat. You have to make sure that your variable is on the left-hand side and your numeric part of the answer is on the right-hand side. Then you're allowed to go by the way the gator mouth or the inequality is pointing, okay? So in yesterday's lesson, or the other day's lesson, we didn't have any word problems, so I'll have to rectify that today. We all love the word problems. It's a real big deal as you move on in your math courses. You get more and more word problems because you're getting closer and closer to the real world, so we try and put more real world problems in there. So let's go ahead and read this. A movie rental company offers 2 subscription plans. The first plan is you can pay $36 a month and rent as many movies as you want. The second plan is pay $15 a month, but you have to pay $1.50 to rent each movie, or $1.50 per movie. Whenever you see that word per, it's kind of a given that what follows it is the variable. How many movies must you rent in a month for the first plan to cost less than the second plan? That's the part that's going to help you set up your inequality statement. All right, so, but first, the very first step in almost every word problem is to define your variable. So that's what we're going to do. Doesn't matter which variable you use. I would stay away from some variables like T's and O's and S's, they kind of look like plus signs or numbers. So be careful with those. Usually X's and N's are what we use for the most part. So I'm going to define my variable as N equals the number of movies that I rent in 1 month. Then I'm going to build my two plans, my left side of the inequality, my right side of the inequality. So the first plan was straight 36 with no variable. The second plan was 15 plus $1.50 per movie. So that's 15 plus 1.5 N. Then I go back and reread the question. It says first plan costs less than the second plan, so I put a less than sign. And now it's easy solving. I move the 15 over, I divide by 1.5, and here's one of the problems with the other way. Like if I were to ask you to graph this one, even though it's a word problem and we don't graph word problems, look what would happen if I graphed this one the old way, not the actual math way. I put the 0 here, I put the 14 here, I put an open circle, and the gator mouth is pointing to the left, so it seems like I should shade to the left. Well, we're saying that 0 is a possible answer. But think about this. We're saying that we could rent -5 movies. Well, that's kind of weird. But let's go ahead and substitute 0 in and see what happens. If I put a 0 in right here, 1.5 times 0, or I should say right here, I'm sorry, is 0. 15 plus 0 is 15, and we're saying 36 is less than 15. That's a false statement, but we just shaded over 0, so we're saying it's a true statement. So be careful. Remember, if you're going to use the which way the symbol points, you have to have your variable on the left. So be careful with that. So back to the word problem. A word problem deserves a sentence answer, and really all I'm doing is I'm using part of the question as my sentence answer. So instead of saying how many movies must I rent, I'm going to say I need to rent more than 14 movies to make the first plan cost less than the second plan. Okay? Go ahead and pause your video here and try this one on your own. Okay, so here we go. I'm going to show you there's the two plans. I forgot to define my variable. I should have said X equals the number of downloads. All right. And I do want to show you that I probably set it up different than you set it up. I didn't follow the way this says. It says second plan costs less than the first, so I should have put the second plan over here and the first plan over here. But because I kept my symbol the same, the correct symbol, it was okay to do it this way also. You'll see that we should have got the same answer. All right, I'm going to pull this down and let you see. There we go, greater than 32, and there's my answer. All right, so if you remember the other day when we were talking about equations, there were times that the variable disappeared, and that's when we could stop and go, hey, is this a true statement or a false statement? And we would get an answer of no solution or all real numbers. The same thing can happen here. I'm not really worried about the always, sometimes, and never true. It really just means, always means all real numbers. Sometimes means, oh, I still had an X there, I solved it normally. And never means that the X's went away and it was a false statement. Just like, so I'm okay with you guys still using all real numbers and no solution. So here's a couple examples of what we just talked about. So the first thing I want to do is to distribute my -2 because I want to simplify both expressions. All right, so we distribute. And from here I notice that I have the same term on both sides. I have a -6x on one side and -6 on the other side. I can go ahead and cross those out because I know they're going to cancel each other out. And then I'm left with -2 is greater than 7. Well, that's a false statement, so it's never true or no solution. I'm fine with either of those answers. Some people move the -6 over and move the -2 over, and you would have got 0 is greater than 9. That's still a false statement. So it doesn't matter which way you do it. You're still going to come out with a false statement. And then this one down here, I have to distribute the 5 and then combine like terms. And again, I see I have a 3x on one side and a 3x on the other side, and I go ahead and cross those out, and I get negative 15 is less than or equal to positive 8. That's true. So this is going to always work no matter what number. So we could say always true or all real numbers. Okay. All right, so here's the last part that we're going to go over. Got a couple slides left. We're going to talk about compound inequalities. So I have a couple of things on here. The top is a compound equality. By the way, there is no such thing. That's why Kevin is looking so confused as he sees that. But there are such things as compound inequalities. A compound inequality just means two inequalities put together that you're expected to solve and or graph from there. So we'll see a couple examples of that. So here's the first example of compound inequalities. This is actually two different ways to write the same thing. If you notice down here that this guy and this guy are exactly the same. So usually that stays written like that up there. But this is considered an AND question. In an AND question, both inequalities have to be satisfied, be true for us to graph it on the number line. Okay? So you've probably been taught before to graph the left one above the number line, graph the right one above the number line, and drop down the overlap. And I'll show you that in just a second. So first we got to solve, all right? So I'm going to go ahead and move the 11 over and distribute the negative 2. Now you could do that in 2 steps. That's fine. Or you could do it in 1 step like I just did. It's totally up to you. Now I can just solve this inequality and move the 10 over by changing its sign and making it positive 10. That's going to give me a negative 8 because 18 is bigger. All right, then I'm going to divide by negative 2. Remember, when you divide by negative, you got to flip that sign. So negative divided by negative is positive. So I got positive 4. Flip the sign to x. So this was a hard one to graph. I don't like to graph when the x is on the right-hand side. So I'm going to take it and pretend the whole thing's on a swivel. Just flip it around, and I get x is less than 4. So I can come down here, put an open circle above the graph, graph it. Now I'm going to do the same thing to this equation on the right. I'm going to subtract 11, distribute the negative 2. It looks exactly the same. All right. Less than or equal to 2. Add the 10. Divide by the negative 2. Remembering to flip my sign, and I get negative 6. So then I come down here and get negative 6. It's a closed circle, and I go this direction. And I'm going to, the overlap comes down here onto the graph, open circle at 4, closed circle at negative 6, and then I shade all the stuff in the middle. And there we have our solution. Now I'm going to go ahead and erase all this, and I'm going to show you a different way to do this one. Okay, so watch this. So right from the start, before I do anything, I want to make sure that this is a true statement, kind of. So I'm going to disregard all of this stuff here in the middle, and I'm just going to read it from left to right. Negative 7 is less than 13. If that's a true statement, then I'm going to be able to go ahead and work this out. If it was a false statement, I could stop right there and say no solution. All right. Most of the time, you will have less than signs on a compound inequality that's an and. So I'm going to go ahead and work this out a little bit different, all at the same time. I knew the first part was to move the 11, and remember I moved it on both of them the same way. So why don't I just do it right here? And then I can go ahead and distribute that negative 2 on the inside, and I get negative 2x minus 10. I get the 2 over here. And then I added 10 both times before. So I just do it on both sides of the inequalities, and I get negative 8 less than negative 2x less than or equal to 12. Then divide by -2. See, I'm just moving everything out of the middle by putting it on both sides. And I get 4. Remember, I got to switch it that way. X, switch it that way. -6. I don't like when the symbols are greater than, so I'm going to take the whole thing, pretend it's on a swivel, and rewrite it like this. So they're less than signs. And then if I graph that, I put -6, I put 4. -6 was a closed circle, 4 was an open circle, and we just shade in the middle. And there we did it that's the same way. It doesn't matter which way you do it. Now I will tell you that if you actually see the word and, if I say 3x plus 7 is greater than 10 and x minus 12 is less than -2, you'd have to do it the other way, where you graph above the number line for both of them and then just drop down the overlap. But for the most part, especially in Algebra 2, if it's a compound inequality, you're going to see it like that. And last but not least is the OR problem. That means only one of them have to be true. So if the left side is true, we shade it. If the right side is true, we shade it. So really, we're just going to solve the left inequality, shade it on the line, then do the right inequality, shade it on the line, and then we live with what's left. All right, so I'm going to do this kind of quick. We're going to add 1 to both sides, so that makes it 8. We're going to divide both sides by -2, so that makes it -4. Switching the sign, and so there's x. So I don't even worry about the right-hand side. I come down here, put an open circle, and I go to the left because it's a less than. All right. Do the same thing over here. I'm going to subtract 4. That makes -15. I'm going to divide by 5. That makes -3. I didn't have to flip the symbol, so that x is greater than 3 or equal to -3. Good. All right. Closed circle. And this one is greater than, so it goes. Now, the key with OR questions is you shade all the way to the arrow, no matter what. It doesn't matter if they're going towards each other or away from each other, you always shade to the arrow. Normally, there'll be a little space in between the numbers, but that's not always. Sometimes you'll just have the whole number line shaded. And that finishes inequalities. I hope you understood.